Example 5, find the area of the largest rectangle that can be inscribed in a semicircle of radius r. Well, the first thing is, since we have a semicircle, we should know that the upper half of the semicircle is going to have the following. So the upper half of the semicircle is x squared plus y squared, which is equal to r squared. Okay, and then we're going to let xy here, it's going to represent the vertex, and we can see that it's in the first quadrant. Okay, now if we look at the rectangle, okay, we have a width of y and a length of 2x. So what that tells us is that the area is going to equal the length times the width. So we have 2x times y. Okay, and so now what we want to be able to do is we want to be able to use the x squared plus y squared equals r squared and solve for the variable of y so that we can then substitute that back into the area formula. So if we solve for y, we're going to get y squared, which is equal to r squared minus x squared, and therefore y is going to equal the square root of r squared minus x squared. Okay, so now what we can do is we're going to use our area formula, and so the area is now going to equal 2x times, now what we solve for y is going to be the square root of r squared minus x squared. Okay, now if you want to determine what the domain is here, the domain tells us that the value of x has to be in between 0 and r. So whatever x is has to be in between 0 and r. So now we can find the derivative of this function. So let's find the derivative of this function. So we're going to find a prime. Okay, so if we use the product rule, we know that we can find the derivative of 2x, which is going to be 2 times the square root of r squared minus x squared. And then we know that, just to write it up here, we know that 2x times r squared minus x squared to the 1/2. So that just gives us an idea of how to find a derivative up here. So that means it's going to be plus, we have 2x times 1/2 times r squared minus x squared to the negative 1/2 times the derivative of what we have inside. Well, the derivative of r squared is going to be 0, since that is a constant, and the derivative of negative x squared is going to be negative 2x. Okay, so now let's go ahead and see if we can simplify anything and make things a little bit more cleaner here. So now we have a prime, which is going to equal 2 times the square root of r squared minus x squared. Okay, so we know some of the things that we can simplify here is that that 2 and that 2 can be simplified. And so we can then take negative 2x times x, which is going to give us negative 2x squared, and then in the denominator we can write the square root of r squared minus x squared. So recall now that what we want to do is we want to set our derivative equal to 0 so that we can find that critical number. So we have 2 times the square root of r squared minus x squared minus 2x squared over the square root of r squared minus x squared, and we're going to set that equal to 0. Okay, now let's add the 2x squared over the square root of r squared minus x squared to the other side. So we're going to get 2 times the square root of r squared minus x squared, and that's going to equal 2x squared over the square root of r squared minus x squared. Okay. So what we can do here is we can write this over 1, and then if we want to, we can just use the cross product since it's a proportion here. So let's go ahead and do that. So if we multiply 2, the square root of rx minus x squared times the square root of rx minus x squared is going to give us 2 times r squared minus x squared. And 1 times 2x squared is going to give us 2x squared. Okay, so let's distribute. So we get 2r squared minus 2x squared, which is equal to 2x squared. And so if we add the 2x squared, the minus 2x squared to both sides, we're going to add it. So we get 2x squared, which is equal to 4x squared. Okay, and let's divide both sides by 4 since we're solving for x. So divide both sides by 4. And let's rewrite this so we have x squared, which is equal to 1/2 r squared. So now let's take the square root of both sides. So if we take the square root of both sides, we're going to have the square root of r squared over the square root of 2. And so therefore x is going to equal r divided by the square root of 2. Okay, so now what we're going to do is we're going to go back and then use our area function. So we know that our area function was equal to the following in part 4. We know that the area was equal to 2x times the square root of r squared minus x squared. And what do we determine that x equals? Well, we know that x is going to equal the following. So we know that x is equal to r over the square root of 2. So we're going to substitute. So we have a, which is equal to 2 times r over the square root of 2 times the square root of r squared minus r over the square root of 2 squared. So we get the following. So if we write r over the square root of 2 by rationalizing the denominator, recall that this becomes r times the square root of 2 over 2. So this is 2 times r times the square root of 2 over 2 times the square root of r squared minus the square of r is r squared, and the square root of square root of 2 is going to give us 2. So what that does is that allows us to simplify. So we can simplify the 2 here, and we end up with the square root of 2 times r times the square root. Well, we can factor out the r squared, and what's left is going to be 1 minus 1 over 2. And so now what we can do is we can factor out the r squared. So that means we're going to have r times the square root of r squared. Okay, we know the square root of 2 can now be multiplied by the square root of 1 minus 1/2. So in terms of algebra, we know that this is going to be r times the square root of r squared is r times, okay, well we know that 2 and the square root of 1 minus 1/2 has the same index. So we can write this 2 under the same radical, and that's going to be 2 times 1 minus 1/2. Okay, so what we're going to get is r times r, which is r squared. Distributing the 2, we're going to get 2 minus 1. So the square root of 2 minus 1 is the square root of 1, which is just 1. So we get a, which is equal to r squared. And so therefore, what that tells us is the area of the largest inscribed rectangle is r squared.